Hi, my name's Tom Singer and I'm a professor of mechanical engineering technology at Sinclair Community College in Dayton, Ohio. Unfortunately, I wasn't able to be with you live this morning via Zoom, so you get the next best thing, being recorded, which means that you have the ability to go and watch this more than once. Today we're going to talk a little bit about how to begin in the additive manufacturing environment and what it takes and what tools you're going to need to look at. So everything begins with a model in additive manufacturing. And so there's basically a couple of different ways to get started. Number one, you can design your own models, or number two, you can grab existing models that are out there. And I guess you can combine the two where you can grab existing models and modify them as another option. But let's talk about making your own models. And it really doesn't matter which CAD program you choose to start with. But choose one that you think will work well for your students. For example, SolidWorks is a really good software tool. However, it's many times not free to schools. And so even at Sinclair, we end up having to purchase our 25 copies of the software. Plus, our students only get to use it on campus because our IT department has not authorized external use based on our licensure. But there are other options. Even though SolidWorks is widely used within the industry, there are other tools that are very similar and work extremely well. For example, Onshape. Onshape is a software tool that was designed by ex-SolidWorks employees. You also have Tinkercad, which is totally free. By the way, these three are totally free. And so Tinkercad is designed for middle school and early high school. So it's more block-based, object-based, as opposed to create something from a unique design. But the third one that I'm going to talk about is Autodesk Fusion 360. And that one is a relatively new software package, about 5 years old, but it is a fully integrated design software solution. So I see this being adopted more and more by industry as we go forward. The best part about it, it's totally free for the school, and it's totally free for the students, and it's totally free for the faculty. So all three of these you could download for free. Now Onshape you have to get through their own website. However, Autodesk Fusion 360 and Tinkercad you actually get through students.autodesk.com. And sign your students up and they get a free access copy, and your IT department is very happy because they have a free copy that can be placed as an enterprise software solution. So one of the key things is get started modeling early in your class. Cover the basics of the design process so they have a pathway to follow to create a design. Talk a little bit about visualization, how things are visualized from front and back and top and bottom, and then actually jump into 3D modeling. And they get it. They can design three-dimensional parts. And there's nothing more exciting than to see your students designing their own parts and being extremely excited when they print out on the 3D printer. They want that hands-on learning experience. But you can also use that hands-on learning experience to sneak in things like geometric dimensioning and tolerancing, just general tolerancing and fits, because when things don't fit together that they made to assemble, then there's a really good discussion that can take place on why it wouldn't fit or how come it may not fit. And then they can also create examples of different fits. And tolerance conditions that they run into. So you can use this as a learning tool and have one team design a interference fit and one team design a clearance fit. So there's a lot of variety that you can use to teach more advanced topics. So let's talk a little bit about our design environment. And there's basically two options. You've got solid CAD models and you've got surface CAD modeling. And the solid CAD model, think about it like a solid chocolate Easter bunny. You bite into the ear and it's totally solid. However, the surface model, when you bite into the ear, it's hollow inside. And so you have a different type of structure that needs to be created to support that. For example, both the solid and the hollow will need something to support the outside structure of the body. So the 3D printer has to create that structure. And they won't necessarily just create it as a hollow object. But you can also grab a lot of free objects that are already created, a lot of gadgets, a lot of role-play and character modeling, and that's from websites. The role-play and character modeling are from like My Mini Factory and Cults and Pinshape and TurboSquid. GrabCAD and Thingiverse are great for gadgets. If you're looking for support tools for your 3D printer that you're receiving, that's a great place to go and find those models in Thingiverse. So one of the things that I actually have our class typically do is we'll print either 1 inch by 1 inch by 1 inch cubes or 3 centimeter by 3 centimeter by 3 centimeter cubes. And we have them printed in different materials, ABS versus PLA versus PETG. And this is to talk about the differences that occur with the specific materials. So for example, is one more accurate in printing than the other? Is there one direction that's more accurate? Is the X and Y more accurate than the vertical Z? And so it gives the students a direct responsibility of creating an exact cube and 3D printing it. Another option that you can do is use that 1 inch cube environment and print them around your different areas on your plate, on your additive manufacturing 3D printer plate, because then you can see which one is the most accurate area that it's 3D printing from. The students want to create their own designs. They want to get involved. They want that hands-on learning. So give that opportunity to them. Don't stifle that creativity. Let them design some really wild and wacky things and 3D print it. It's inexpensive overall to make that happen. Just make sure that they follow that design process so they know when they're successful going through that process. So just a quick heads up, we had a current project that we created, or a project last year, which partnered with Tennessee Tech and Somerset Community College, partners in this grant. And what we did is in Sinclair, we came up with a problem that how can you open a carbonated bottle cap without having to twist it with your wrist? So what tool could we create to help somebody who can't twist with their wrist open a bottle? And this is actually a true issue, because if you have surgery and or other issues that you may have with your wrist, you can't necessarily twist that cap open, especially if it's carbonated. So we created a tool that was developed for that purpose. And that particular tool is now going under provisional patent for the students. So the students own the patent on that design that they created. And so the Tennessee Tech graduate students and the Sinclair design student has that capability of taking that product to market. We're currently working on a design to open up 5-gallon buckets. If you've ever tried to open up a 5-gallon paint bucket or a 3-gallon drywall mud bucket, they're not easy to get your fingers under the lip and pop all the different lid areas open. So we're creating a tool to help make that happen. So hopefully that'll become as successful as this bottle cap opening tool. They can also grab models out in the general space and then go and edit those and make them their own. So there's a lot of cool things that they can do. And if they create something unique, have them post it to Thingiverse if they're not opposed to sharing it, because that makes it a much more elegant way for them to go into a job interview and say, hey, bring up my Thingiverse, or here's my Thingiverse part that I've shared with, and here's how it works, and here's a copy of it. So it works out really well for job interviews. So additive manufacturing is the next leap. So the prototyping, plastic modeling is one step. Now we're moving into the actual manufacturing of metal-based parts using the same technology basis. And you're going to hear over the next day how big of a need there is for these technicians in industry. They're ramping up, and we need to be able to provide them the workforce to help accomplish what they need to do. And so there's a lot of different capabilities, and you're going to, like I said, you're going to hear more and more about this over the next couple of discussion presentations. And so initially focus on low-cost CAD in your labs. Learn from your part failures. Instruct on the process and then have the students check off on it so they know how to use the machine on their own. Most of the machine parts are easily replaceable and available out on the web. So you've got the ability to repair and replace most of the parts if something were to break. This is a quick slide. If you happen to have an old powder 3D printer, don't get rid of it, because the technology that was used in the powder printing for the Z-Corp printers is actually the same concept technology that's used in metal printers at a much lower cost. So that is something that's unique, and there's actually some schools out there that still have old Z-Corp printers that can demonstrate that concept. So what truly are your next steps going forward? Obviously you're going to be getting some training, but you got to practice and play around with it. So jumping in with the students is a good way, and I don't know is okay. And the students will help find the answers with you. And just be upfront with the students and let them know that you're getting started and you're not 100% of an expert yet, but you will be over time. Inexpensive printers. Couple of things about those. The sub 300 printers are okay, but expect to have more failures and more setup and more variability in your parts. The $400 to $600 to $700 printers are way more stable. Hardware and software wise, significantly more stable. They come with heated beds, could be auto leveling. That's not a requirement. That's kind of a bonus feature on some of them. Variable temperature control to run different materials is also important. If it comes with an enclosure, that helps keep the overall temperature more stable as you're building larger objects. So even if your printer doesn't come with an enclosure, something very simple as a basic box, not a cardboard box, but a plastic acrylic box put over it will help keep it more stable in terms of temperature. And keeping your bed temperature stable helps the adhesion process. Buy decent PLA material. I can't stress that enough. Spend $20 a spool for the PLA material. I use Hatchbox material. It's some of the most stable stuff that's out there. It's very consistent. It works very well. All the colors work really well, including the wood option and the flexible PLA option. We've run varieties of different materials, and that seems to be the most stable and consistent. Keep your desiccant packets, so when you have to Ziploc bag a material roll that you're finished using and changing the color or material, that you can store it with some desiccant, because PLA and ABS are moisture sensitive, so you want to make sure that you maintain that moisture environment. Ed's got a great setup to do drying, and you could actually do that drying process in one of the food dehydrators and things like that. But again, desiccant packets are your first line of defense. Well, have a great day. Enjoy the learning opportunity that you're going to have and the opportunity to create a very cool design product here by the end of tomorrow. Take care, and we hope to talk to you soon. Bye now.